Hello guys, good morning, welcome to benzblog. Now our topic for today is ADVR DAS 440. This is made from KUTAI, and this one is you can replace this one for the AVR as ES 440. This one is you can use for the stampered alternator, and this one is also good AVR for in this kind of application. So here we are all talking about the functionality and the troubleshooting for this kind of ABR, and which connections is necessary for this, and which is the voltage and sensing, and where we can adjust the stability and everything for this kind of ABR. So if you have some questions or doubts, just comment down the YT. And those who are people who are not yet subscribed, just hit the notifications and hit the subscribe button down there so you can so now we're going to talk about it. So let's start. So now let's start our topic. So as I told you, this one is ADVR DAS 440. This one is you can replace for ES 440 AVR, and also has same functionality. So now I will show you the pictures for our KUTAI AVR, and here is the full picture for this AVR. So let's read it. This analog digital single phase detections excitation current 4 amps for use to brushless and self-exciting shunt generators. It is also compatible, as I told you, it is compatible compatible to Stanford AS440 AVR. If you don't have this AS440, you can use this one as the replacement. And also this AVR also is a good AVR, and you have no problem with it. Just connect properly and follow the manual instructions. So here is the specifications for this type of AVR. So sensing input, this is a single phase sensing input, so you can apply as 110 to 220 VEC as stated here. So this one is single phase wire connections, so it will always depends on the connections. If it is 12 blades alternator, so you can, if the connections is Y connections, so you can take in the middle connections this one, and if you are in the what we call in the double Y connections, so you can take it from line to line connections. So here this is also applicable for your 50-60 applications. So I will show you later on the connections for this, and let's talk about first the specifications of it. So power input is 7 to Z, it is 40 to 300 VEC, and it is also single phase wire. So from frequency you can apply, this one is 40 to 60 Hertz. The excitations of this AVR is we have the F1 and F2. It is correspond to F1 is positive for your exciter, and F2 is your negative. So this one is 110 single phase continuous 33 VDC, so at 4 amperes. So this one is always at DC voltage. So this maximum voltage you can apply for this it can produce, and this excitation level is up to maximum 45 VDC at 7 amperes for only 10 seconds. So here to 20 single phase continuous at 63 VDC at 4 amps. So here you can apply, or he can give the output voltage at 90 VDC 7 amperes 7.5 amperes at the 10 seconds maximum. So resistance minimum at 15 ohms, maximum at 100 ohms. So fuse specifications is 5 by 10 mm. This is the dimensions, the length, at 6.3 amps. Okay, so if you have an external potentiometer, you can apply this one at 1 kilo ohms. So watt potentiometer. Okay, later on I will show you the connections for that. For now, this all specifications I'm going to simply read to you. So this voltage is less than to positive negative 0.5% within the 4% range engine governing. So the build up voltage for this one is started from 5 VAC to 25 Hertz residual voltage. So here is your voltage if this one is no excitations, only the residual voltage from 5 VAC. Okay, so soft starts ramp time is 4 seconds plus minus 10%. So it is typical system's response at less than 20 milliseconds. Okay, so EMI suppressions, this is internal electromagnetic interference filter. He has also the interference filtering. So how about here this side? So this one is quadratron drop input, or this one is your drop CT, is your connections is S1 and S2, and this one is less than at 0.1 ohms. So the sensitivity for this one is around 0.07 amps for 5% drop and power factor of 0. So that is equivalent of 0. So the drop adjustment is the maximum input is around at 0.33 amps. Okay, so the analog voltage input, so meaning this is for your paralleling connections. This is what we call your biasing connections. This one you can connect at E1 at E2. This input resistance is more than 2 kilo ohms. So the maximum input is plus minus 5 VDC or 10 VDC. Okay, so the sensitivity, there is the sensitivity adjustment there, you can adjust, but later on I will also explain to you. So this one is 1 VDC for 5%, generator board stream adjustable. So here down is under frequency protections, factory preset at 50 Hz, knee points at 45 Hz. So 60 Hz, it is the knee points of 55, easy. So over excitations, we have here set point 40 at 110% VDC at power input of 220. So set point of 110 VDC plus minus 10% at your input of 220 BAC. Okay, so this one is we can work out at the temperature of 0 to 60 degrees Celsius. So storage temperature at 85 or 40, negative 40 to 85 degrees Celsius. Okay, so they have also the vibrations. Here is 5.5 GS at 60 Hertz. Okay, so dimensions not necessary. So let's go now for our adjustment and everything, potentiometer. So as you can see here, here is our Z1 and 8. So as I mentioned in the ES440, this one is a what we call that one is the external winding, or we have your extra winding or auxiliary winding, whatever that one, the words they are using, that is auxiliary winding. You can use it the Z2 and 8. So the sensing point for your AVR is 8 and 7. As it is mentioned here, you have the sensing input from 90 up to 260 VEC. Okay, it is connected from 8 and 7 terminal. So down here, if your excitations connections is from F1 and F2, so this one is connected to the generator excitation failed. So around here in this point, you can adjust your voltage potentiometer here. This is your adjustment here. So 1 and 2 is your external AVR and port short it if you are not use it. Okay, so this is your variable resistance. So here you can use the applications like there's external variable input. Okay, if you have the potentiometer, you can connect here. Okay, so you have 2 wires only. You can connect for this one, so you can adjust externally. So you have in the panel connections for your voltage potentiometer, so there you can install that. So no need to open up your AVR from the alternator, so you can adjust it outside. So down here is line to line, short for 110 volts, open for 220. So number 3 is not used. So your line to line, so this one is stated here that if you're going to short it, so you can apply the sensing point for your 110 volts. If you open this one, so you can apply for your sensing voltage of the range of 220 volts. So this is your drop sensitivity adjustment. So it is here. Okay, so this is your drop adjustment. So S1 is S2 is your drop CT connections. So as stated here, you can apply the sensitivity at 0.07 amps at 5% drop to the maximum of 0.33 amps. Okay, so here is your A1 and A2. This one is applicable for your paralleling connections, and my words, this one is for your biasing, and this one is connected from your module. So this one is controlled by your module connections. Okay, this one is you can apply if you are in the synchronizing or the paralleling application. So here is your trim for your analog voltage. So you can trim that one if you want only the maximum for 0 to 5% VDC or the maximum of 10 VDC. You can adjust this one here. Okay, so here the excitation protections, here you can adjust to the maximum to the minimum, where for the safety for over excitations. Okay, so to avoid the over excitation, so you have to limit that level. Okay, around here is your stability. If you have some not normal voltage, or if there any fluctuations happen to your voltage, so here you can adjust those stability. Just either you can plus minus adjustment, that one depends on how big the fluctuations you have. So just slowly adjust minus or positive or higher or low adjustment for that until it is fix your problem. So in here, this is the connections where you can select the stability setting. So AB is around 500 to 50 kilowatt, and BC is 100 to 500 kilowatt. AC if you want fast reactions at 100 kilowatt, and the slow reactions is BD. AC is the fast and BD is slow. So if it is depends on the alternator applications. If you are having the big alternators, like, so you can select here. It depends on, just look to the nameplate for the alternator, so you can rely on which connections you can link in order to work at your what you want. Okay, so here is your under frequency adjustment. This is all about protections to avoid over or under frequency. So it's internally have the protections, that one, so it will automatically shut down internally. Okay, so here is our 50 and 60 connections. So here is the 50 C. So if you link this one, pin 50 and C for the 50 Hertz. If you link this one 50 and C, that is equivalent for your 50 Hertz applications. And if you link the C and 60, is applications for the 60 Hertz application. So this is the light for your under over excitation, and this is the light for your under frequency. All this one is for your indicator light. Okay, so here I will show you the connections. Okay, so here is your alternator, and you have here the neutral RST, or this one is red, and what is this? This is what we call this. We say this one is UVW. So this one is your U, this one is your V, and this one is your W. Okay, so this one, it should be RYB in our color coding. So red, yellow, and blue. So here it comes. So here, as you can see here, this is your drop city. It is connected at your S1 and S2. So you can select either in yellow or in either of the line. You can connect that one for your drop city. And here is your 1 and 2 is for your external potentiometer. It is at 1000 or 1 key ohms. This one here is for your sensing voltage ranges. So if it is closed, this one is can take your voltage sensing at 110%, but if you remove this one, it will be at 220 range for your sensing. Now your F1, F2, it is connected at your exciter field. Medyo bulol. Okay, so this one is your exciter field connections. And how about this one, 7 and 8? This one is your voltage sensing connections. Okay, so this one is showing here is your like double Y connections, because it's directly to the line connected. Okay, this one is closed because there is no auxiliary winding which is not connected, so it is just closed, this one. But if you have the external or auxiliary winding, this one you can connect it here. Okay, so the voltage, this one is around 300 plus. So that is 90 to 300 plus, I think, as I stated previously. So here is same connections at the 220. Okay, so this is the 380. The previous one is the applications for 110 and 220 connections, and here is your 382 for 40 VC connections. So meaning this one is at the big Y connections. Okay, so he take the neutral from here and the line, so you can take around the voltage is not because if you say line to neutral, so you can take only around 220 above, like voltage like that. So So here is the voltage. This is the voltage output for this alternator. So this alternator here is the voltage output at 110 to 20. Okay, so it is clearly, it's the same connections of the rest and everything, so there is no difficulties to identify. So the voltage here, output of this one is 380 to 440, so that's why they connected this one into the line and from your neutral, so you can take around 220 voltage. Okay, from here, so the voltage output for this one is 110 to 220, so they take it line to line voltage, so meaning this one is at the connections is double Y connections or double delta connections, and here is your big Y connections. Okay, so do not be confused. So around here is as you can see, you have the auxiliary. I cannot speak properly now. I don't know what happened to my tongue. So this one is our auxiliary winding connections. So now, as you can see here, this is connected from Z going to your 7 is your also line. Okay, and it is also connected to 8 is in your line also. Okay, so don't be confused for that. So as usual, if you are having the problem for the AVR, it is commonly like for example, you don't have the voltage same as what I stated to the AS 440, and the rest of the AVR that I am talking about here mostly are the same troubleshooting. If we encounter some problem for our AVR, same as the troubleshootings as I told you from my previous blog, it is easy this one to troubleshoot if there is some problem, because just look for my previous blog for the rest of the AVR, so you can easily identify for those problem. So for now, I am done for the explanations, and if you have some questions or another video that you want to talk about here, just comment down below so we can talk about it. So don't be shy to ask some questions or related to our topic, so I can also reply to you, or I can help you if I know the rest of the troubleshooting, if I know the rest of the connections. Depends on what your questions to me. So once again, Beans Blog is here. I'm happy that you're watching for this video, and I hope that it is, can be help to you as long as I am doing this vlogs as also for you. So thank you for watching. See you again in my next vlog. Bye bye.